don't use this phrase really often, like too often, but this is one of my favourite questions. I don't know. It's not even maths. I just think it's a wee bit common sense almost. Okay. The only mathematical thing here is knowing that you've got an X, Y, and Z um, system, but actually that's just a three-dimensional. It's almost it's a bit like um, battleships, but with an extra element. People can find J5 and A3, and we're just adding another element to that. Okay, so I think this is great. Okay, four marks we're going to get. Um, right, yeah, 4 marks we're going to get, and some of that's based on this. So I think these kind of questions, when you see them, great questions. Okay, so A's on the diagram, don't need to know that. B's on the diagram, don't need to know that. It's a rectangular base pyramid. Okay, right down the coordinates of B. So it's B over there. So what are coordinates? Coordinates are just an X, a Y, and a Z. Yeah. So how far have I gone in the X direction, then the Y direction, then the Z direction? Okay. So there's my X-axis shown here. Yeah. There's Y and there's Z. Now for free, we can say, well, Z is going to be 0, isn't it? Because we're going along something up, but then we're not going, we're going along the page, into the page, but not up. Okay. So right away, I know that's going to be 0. The next thing to work out really is how big this pyramid is. So it shows a rectangular base pyramid. Okay, so we've got 2, 0, 0, and in the middle we've got 5, 2, 6. So what that's saying is the height of it is 6. So right now we're not really concerned about the height. We're thinking 5 and 2. So if I were to draw this out in plan, okay, now the A is at 0.20 and the centre is at 0.52. So from 2 to 5 is 3. So I'm going to have to assume that there'll be another 3 over here. Okay, so that's like 3 units and 3 units. Okay. So if that's the case, that's 6. So 2 plus 6 would give me 8 to get to that corner. Okay, so that corner would be 8, 0. Okay, but the point is the length of it though is 6. Okay, so the middle's 5, this corner's 2, so that's like 3 is the distance from here to here. So that's going to be the same on the other side. Okay, going in the y direction. In fact, I should have said, sorry, this was the x direction and this was the y direction when I was looking at plan. So we're looking at it down this way. Okay. So I've got 0 in the y direction, and then I've got 2. So that means from the beginning to the middle is 2. So that means this is going to be 2 as well. And that makes sense, it's a rectangle because that's 4 and this is 6, okay? And that's probably the only important word there, rectangle, not a square, but rectangle. Okay, so that's 4 and that's 6. So we just said that the coordinate of this corner then is 8, 0, 0. Because we're just doing 2, 0, 0 plus 6. We're moving along 2, and we're not going anywhere on that coordinate. But then if we want to move to here, we're moving 6 along, so it's 8, 0, 0. Then to get to B, we need to go 4 into the page. So it's going to be 8, 4, 0. Okay, and you just get 1 mark for that. So some people are probably saying, oh, I hate that, it's really hard, but I think that they're quite good fun. And if they ask you for another coordinate, it's just an easy mark, I think. Okay, so just take your time, draw a diagram, maybe draw it in plan. But yeah, maybe the only thing that was tricky there was knowing it's a rectangle and thinking that the middle, from the edge to the middle was then doubled. That was going to be the only leap. Calculate the length of edge AV. So there's AV. In fact, I'll highlight it in. Is that my orange pen? It's still a red pen. Red pen. We'll highlight it in orange. Okay. So I would say that was part of this triangle. Okay. So the one is to work out the 2 lengths of the triangle. Okay, so I'm going to call that A, I'm going to call that B, and we're trying to work out AV. Okay. There's A, B, B. Okay, so instantly we know what B is because, like we said, we've got the height of the pyramid. So that's going to be 6, isn't it? So 6 for B. So B, 6. A little bit trickier. Okay, so on our plan over here, let's just redraw that with just dimensions on it. So we said this was 6 and this was 4, and we're looking for this dimension in here, aren't we? Okay, so to get to that, that's going to be 2, that's going to be 3. Okay, so to get to A, we need to do a little bit of work. There's A there. So that's 2 and that's 3. So A is equal to 2 squared plus 3 squared square root. I do apologise for that square root. Okay, so just a Pythagoras add question for that one. Right. So that's going to give us the square root of 4 plus 9, which is the square root of 13. So we're just going to leave it as a surd just now, okay? Because I think the question must want that to come out in the wash at some point, okay? So we know that A is root 13. So to work out what AV is up here, we're just going to do the same process where AV is equal to root 13 squared plus 6 squared. Okay, so 13 squared is just 13. Anything's the square root of anything squared is just, you're basically undoing the square root. So that's 13, and then 6 squared is 36. And I forgot the most important bit. I could have written the equation like this, but I'm just going to save us some time, and I forgot to put in my massive square root over the top. Okay, square root of that. So 36 plus 13 is going to be 49. So it's root 49. Okay, and that would be in, it's not told us, so I'm just going to say 49. Now, root 49, can we simplify root 49? Does 49 ring any bells? Yeah, that's 7, isn't it? Okay, so think of your squared numbers: 2 squared, 4, 3 squared, 9, 4 squared, 16, 5 squared, that is a 5, 6 is 36, and 7, 49. Okay, so yeah, try them out. You should really know these up to 20. I'm kind of quite bad actually. I'm not totally great above 15 as far as I go. But yeah, you should remember them. Okay, so that's right. Let's see what the marking scheme has to say. All right, let's have a look. So 3. Yep. So you get a mark for this. Oh, that's interesting. So they in the marking scheme didn't quite work out as root 13. They just substituted that into here. But okay. Yeah. So a mark for that, and then a mark for substituting into here, then a final mark for 7. Okay. So yeah, not a terribly difficult question. Question 8. Should have enough time for this. Solve the equation. Okay, so we've got fractions. We were talking about fractions before, taking away. If you want to add or take away, remember we did smiling cross. Okay, so we could do that to work out a common factor. That's one way of doing it. We'll do that method to begin with. Okay, so let's just look at this bit in isolation. Okay, so we want to manipulate this to add them together. Okay, so I've got 2x divided by t. So we're just forgetting that other 2x over there just now. Okay, ignore him. Minus 5 divided by 6. So to get a common factor, we're going to do a cross. That's going to give us 18. And then 6 times my 2. So now we do our cross. So that was our smile. We did our smile. Now we're doing our cross. 12x. And 3 times 5 is 50. So that is 12x minus 15 divided by 18. So that's what that comes out as. We can put them together. Okay. Now we said that 12x minus 15 divided by 18 is equal to 2x. And now we can start to rearrange, can't we? So let's put our working line in. So once I get x's to one side, numbers to the other. So let's get rid of this 18 first. Okay, so how do we get 18 over? Well, we're dividing by it on the left, so we need to times by it to get it onto the right. Okay, so that's going to give us 12x minus 15 is equal to 36x. Okay, moves it over. Now let's get we put x. X is onto the right hand side then, okay? So let's move this x over. Okay, so it's plus 12x on the left, so we're going to have to do negative 12x to move over. So that's going to give me minus 15 is equal to 24x. Okay. And then let's just get x on its own completely. So how do we get rid of the 24? How do we move that to that side? Well, we're going to divide by 24 because we're times it on that side. So minus 15 divided by 24 is equal to x. Now, can we divide? Can we reduce that any? So remember what I said about the divisibility rules before? Okay, so 5 plus 1 is 6. 5 plus 1 is 6, and 2 plus 4 is 6. They both divide by 3, so they should both divide by 3. So that would give me 5, and that give me 8. So it should be minus 5/8. Okay. Looking at a marking scheme. Yep. You're getting a mark for multiplying through by 6. So you're kind of getting a mark for your first mark for the first step. You're getting a mark for your rearranging, and then you're getting a mark for solving. Okay. Now, I did the smile and cross method. The other way you could have done was what the markings got, which is just to do a straight times by 6. Okay. Now, if you do that, you're considering the whole equation. Okay. So what we're trying to do is get rid of the denominators. We say 2x over 3 minus 5 over 6 equals 2x. If we just times everything by 6, okay, so say we do 2x times 6, 5x times 6, 2x times 6, okay, 6 here cancels out, and then the 6 divided by 3 here is going to cancel out, give you a 2 on top, so you'll get 4x minus 5 is equal to 12x, okay. That's possibly an easier way of doing it actually, but that relies on understanding that by multiplying through by 6, everything by 6, okay, when you do it this way, you've got to look at both sides. With the smile and cross method, you started off just looking at that as well. But it relies on you understanding multiplying through by 6 is going to get rid of both denominators, okay. And because that was 3 and 6, that gave us quite a nice number, okay. But yeah, if you multiply through by the highest denominator, it should get rid of them. Hopefully, in a tidy fashion. Okay. So, yeah, that's another way of doing it as well. All right. Yep, plenty of time.